Myself, Basavara Shivananda Parapnavar. My subject is chemistry in PIPSM BSc. USMS number is U02EY23S0058. My topic is photochemistry. Introduction. Photochemistry is the branch of chemistry that deals with the chemical changes brought about it by the absorption of light. Unlike thermal energy reaction which depends on heat energy, photochemical reaction are initiated by photons, particles of light usually in the ultraviolet or visible region of the electromagnetic spectrum. When light of suitable wavelength strikes a substance, it can be absorbed by its molecules, leading to an existed state. These existed molecules have higher energy and can undergo various physical and chemical energy and have undergo various that are not possible in the ground state. Photochemical reaction play an important role in photosynthesis and photography, vision, and atmospheric reaction. Changes are processor that occur due to the absorption of light energy, usually UV or visible light by atoms or molecules. The laws of photochemistry. There are two fundamental levels that govern in photochemical processes. First one, Groth-Draper law. Second one, Stark-Einstein law, photochemical equivalence. First one, Groth-Draper law. Statement: only that light that is absorbed by substances can bring about a photochemical changes. This law was proposed independently by Theodor Groth in 1817 and John William Draper in 1841. He emphasized that mere exposure to light is not enough to initiate a photochemical reaction. Absorption of light photons by the reaction species is necessary. Explanation: when a molecule is exposed to radiation, only those photons whose energy matches the energy differences between the molecule's ground and existed electronic state are absorbed. This energy absorption exits that molecule and enable it to undergo a chemical change. In the radiation is not absorbed. For example, if the light wavelength is not within the molecule absorption spectrum, no photochemical reaction will occur. Example: fluorine gas absorbs blue light and undergoes photodissociation to form chlorine. Cl2 plus Hv is equal to 2Cl. Importance: the Groth-Draper law explains why only specific wavelength of light cause reaction. It forms the basis for understanding light absorption spectra and designing photochemical experiments. Second law of photochemical. Second law, Stark-Einstein law. Statement: each quantum of light absorbed by a chemical system, only one molecule is activated for a photochemical reaction. In other words, one absorbed photon's activities one molecule deals with in the primary photochemical step. One photon is equal to existed molecules. Explanation: when a molecule absorbs a photon of energy is equal to Hv, it is raised from the ground state to an existed state. The existed molecule can then undergo a chemical change, although the subsequent reaction may involve chain process producing many product molecules. The initial step obey this law strictly. Example: in the photochemical decomposition of hydrogen iodide. Limitations: this law applies only the primary process, the absorption of light and formation of existed molecules. Difference between photochemical and thermal reaction. Chemical reaction, thermal reaction. Light energy, thermal reaction, heat energy. Chemical reaction by absorption of photons, thermal reaction by heating the reactants. Chemical reaction many occur even at low or room temperature. Thermal reaction require high temperature. Chemical reaction existed molecules, free radicals or ion. Thermal reaction activated molecules due to heat. Chemical reaction depends on heat intensity, wave length of light. Thermal reaction depends on temperature. Chemical reaction generally strong selective. Thermal reaction generally less selective. Example explanation: photochemical reaction CH4 plus Cl2 Hp CH3 plus Cl HCl. Second one, thermal reaction 2 KClO3 heat 2 KCl plus 3O. These examples show that photochemical reaction depends on the presence of light of specific wavelength, while thermal reaction depends. Quantum yield definition: the quantum yield theta of the photochemical reaction is defined as the number of molecules reached or formed per quantum of light absorbed. Theta is equal to number of molecules reacting or product formed divided by number of quanta absorbed. It produces a measure of the efficiency of photochemical process. Types of quantum yield: higher quantum yield, theta is less than 1. This indicates that many molecules react for each photons absorbed. This usually occurs when a chain reaction is initiated by one absorbed photon leading. Interpretation: if theta is equal to 1, each absorbed photon causes one molecule to react. If theta 2, chain reaction occurs, one photon initiates multiple reactions. If theta is equal to 1, some existed molecules lose energy through non-reactive pathways like fluorescence or internal conversion. Factor affecting quantum yield. First one, efficiency of energy absorption. How well the molecule absorbs light. Second one, deactivation process. Competing process like fluorescence or heat loss. Third one, chain mechanism. Propagation and termination steps affect yield. Fourth one, quenching effect. Collisions with other molecules may deactivate existed steps. Example: high quantum yield reaction H2 plus Cl2 Hv2HCl. Second one, low quantum yield reaction 2HI heat H2 plus I2, energy loss via collision. Applications of photochemistry. First one, photosynthesis. Plant convert CO2 and water into glucose using sunlight. Second one, atmospheric reaction. Formation and decomposition of ozone. Third one, photographic processor. Decomposition of AGBR on exposure to light forms the basis of photography. Fourth one, photopolymerization used in making plastic and resins. Fifth one, solar energy conversion. Photovoltaic clear cells convert light into electricity. Thank you all of you.